Okay, I've got two more examples to do for you. We're going to establish the identity 1 plus sine theta over 1 minus sine theta equals secant theta plus tangent theta all squared. Alright, let's start with the left-hand side. Alright, now if I look at this left-hand side, there's really nothing for me to do. There's no fractions to put together, or, I mean, I could try to take them apart, but I'm not really sure if that's going to do anything. There's no factoring to happen. This is the case where if something looks kind of like this, you want to see, I wonder if I could create a Pythagorean identity, right? And what really clues me into that is this 1 here, and then the fact that I have a sign, right? Because I know that those are both in one of the Pythagorean identities. Alright, so what could I do to, get a Pythagorean identity here? Well, I'm going to multiply the top by 1 plus sine theta, and the bottom times 1 plus sine theta. Now, why did I choose 1 plus instead of 1 minus? Well, the thing that I'm headed for up here doesn't have a denominator. So if I can get the denominator of this thing to kind of go away, that might be helpful. That's kind of what I'm thinking. We'll see what happens. Alright, now on the top I get 1 plus 2 sine theta plus sine squared theta, right? Multiply that out. And on the bottom, this is now, if I multiply and FOIL, I get 1 minus sine squared theta. Okay. Well, I got my trigonometric identity on the bottom. It's true that 1 minus sine squared theta is equal to cosine squared theta. Yeah? And this numerator, not sure what I can do with that yet, but let's just write it out again. I'm going to look back at what I'm going for. It's always a good idea to kind of keep track, thinking about, okay, I want things in terms of secant and tangent. Well, secant is 1 over the cosine. Alright. And tangent is sine over cosine. Interesting. Well, look, I have some 1 over cosines almost, and some sine over cosines almost. If I separate this up into separate fractions using the LCD. So this is something else I suggested doing in my hints. So every term in the numerator gets written over the common denominator. Alright, now since I'm going towards secant and tangent, let's put it in terms of secant and tangent. So this is 1 over cosine is the secant, but this is 1 over cosine squared, so this is secant squared. Okay. Now, if I do this, take one of those cosine squared, one of those cosine thetas from the cosine squared, right, and put it under sine, that's going to give me tangent, and this 1 over cosine is going to give me a secant. I like this. Okay. Then we know that sine over cosine is tangent, but this is squared, so this is tangent squared. Alright, so let's get the final stuff written in terms of secant and tangent, and then see what we've got. Plus 2 tangent theta secant theta plus tangent squared theta. Let's go back to what I'm looking at. Right here, notice that this thing here, it's the square of a binomial. And when I look here, I see a perfect square trinomial. Notice there's a square up front, a square in the back, and 2 times the square root of each of those. So I can factor. Yeah! This becomes secant theta plus tangent theta times secant theta plus tangent theta. Aha! Which is secant theta plus tangent theta quantity squared. Yeah. You know, sometimes you don't know where you're headed and you take a chance. I thought we were headed to be finding a Pythagorean identity in order to get, tangent squared and secant squared somewhere. And I did go that way, but it turned out that really I was going to factor a perfect square trinomial. Awesome. Alright, I have one more example to show you. And this is a fairly simple example. It's a fairly simple thing to do once you recall something from a previous chapter. We're going to put together the trigonometric functions with the natural logs. Okay, so we're going to take the natural log of the absolute value of tangent theta equals the natural log of the absolute value of sine theta minus the natural log of the absolute value of cosine theta. Why the absolute values? Well, because remember that the domain of the logs is greater than 0. All right, so we're going to make sure that that happens by having the absolute value of each of these. All right, now on this one, I'm going to start with the right-hand side because it's more complicated. Not a whole lot, but a little bit. So natural log of sine theta minus natural log of cosine theta. Remember that if you subtract two logs from each other, that's the same thing as taking the log of their quotient. Awesome! So we have the natural log of the absolute value of sine theta over the absolute value of cosine theta. Well, we know that the absolute value of each of the cosine and the sine are positive, so we can put them all underneath one absolute value bar, because that's going to be positive also, right? So we have the natural log of sine theta over cosine theta. And what is the sine theta over cosine theta? It's tangent theta. So that's exactly what I was trying to establish. I'm done. Yay! Good luck. Have fun.